afternoon, everyone. Let us now get started. There's going to be a kind of deja vu thing going on today. In other ways, hey, I've seen a lot of this before, and that's fine because you probably have. But we're going to do what they describe as the unit circle. And I'll start with the guy that we all should have a copy of somewhere. It's easier if you look online, you could probably get a much better, prettier version of what I'm about to try and draw. It's called the unit circle. And what this does is it basically is a way of putting a lot of information about the sines and cosines in particular and various angles. And so on this you have, and I won't do all of them because they're just far too many. But you have a guy that looks like this. And this point here, here, and here, and obviously I'll put this one in. This has coordinates 1, 0. This guy has coordinates 0, 1. And these all have coordinates. And this point here has a coordinate, so does this one. And finally, this one. And the coordinates, the X and Y coordinates, tell you what the sines, cosines, and tangents of various angles are. I'm seeing if I can find a green pen. Oh, good, I have. So this angle here is going to be pi upon 6, or if you prefer, 30 degrees. So you start here and you go to this one, you would get pi upon 4, or if you prefer, 45 degrees. And then if you start here and you go anti-clockwise to this point, and this one here is pi upon 3, or it's also called 60 degrees. So far, so good. Now, this guy here, which is kind of the x-axis as well, this has these coordinates. Isn't that just 0 degrees or 0 radians? And what one would this vertical line be? What angle would here going right up to the y-axis be called? What angle?
90.
90. And if you want to, pi upon 2. Agreed? And sometimes questions are radians and sometimes questions are degrees. So you have to be kind of ambidextrous, right? That when somebody says 30 degrees, you should just kind of know it means pi upon 6, right? You just, boom, boom. It's like capital A and little a, right? They're both A's, just different things, right? Now, also it's helpful if you have these written down. It's even more helpful if you've memorized them. You should know the X and Y coordinates of any one of these 3 points, right? So this one here is √3 upon 2, comma a half. Does anybody know what the coordinates of 45 degrees is? Because that's probably the easiest one of the 3 to remember. 45 degrees, pi upon 4. What is the X and Y coordinate of this point?
Is it √2/2 and √2/2?
You nailed it. That's exactly what it is. Now, even if you can't remember this point, if you look at the other 2, you could have a good guess at what the third and final point is. This one. Any guesses, or hopefully just what's the coordinates of this top one?
Is it 1/2 and then √3/2?
Right. Do you notice that there's a lot of symmetry in these questions, right? Especially the 30, 60 degree one. Now, I'm not doing the others, but isn't there a whole load of ones, 1, 2, 3 here, another 1, 2, 3 here, another 1, 2, 3 here. And, you could, if you've got your unit circle, you're good to go. Now, what we can tell from a coordinate is that the X coordinate of any point is the same thing as the cosine of the angle, and that the Y coordinate of any point is the same as the sine of that angle in a unit circle. Agreed? You remember that? And if you wanted to find the tangent of any angle in the unit circle, wouldn't you take the y coordinate and divide it by the x coordinate? And this is true only in a unit circle. That means a circle whose radius is 1. So what I've just done here is called a unit circle. That means its radius is 1. And this property is true. Agreed? Right. Now, if you make your circle bigger or smaller than a unit circle, right? So you have a radius we'll call r. The relationship is a little bit trickier. The cosine of theta then is going to be the x coordinate over r. The sine of theta is going to be the y coordinate over r. And the tan of theta is technically the sine divided by the cosine, which doesn't have an r in it. Because, well, I guess it did have an r, but the r's get cancelled out with each other and they're not there anymore. Because the top one has an r, the bottom one has an r, they cancel out, and so the r's disappear. So far, so good. Now, I'm also going to tell you a thing that you should remember. And can you remember all students take calculus? Remember that one? The 4 quadrants? That tells you when a sine, cosine, or tangent are positive or negative, right? You can also do all smokers take cancer if you're a kind of depressing person. We call this region the first quadrant, the second quadrant, the third quadrant, and finally the fourth quadrant. And there's the x-axis, here's my y-axis. And just to put some numbers on this, 0, I'll do it in degrees, 90, 180, and 270. You remember those guys? So a lot of what I've just done has been things that you have done in the past. So here's something that's new. Imagine that you're given a circle, not a unit circle, right? But a circle that might or might not be a unit circle, right? It might have radius of 1, could have a radius of 21. And in this circle, you're given the coordinates or the partial coordinates of a point, and you will then use that to find the other coordinate. So let's suppose I tell you that I have a point P and it's in the 4th quadrant. So that makes it, I'm not being accurate, that makes it somewhere down here, right? And let's suppose I tell you that, what is it? That in this case, it lies on the unit circle as well. So this one will be a unit circle. And I would like to know that guy's coordinates, and what do you get told? You get told that this guy is -5/13. So I know the y coordinate is -5/13, and you're being asked to find the x coordinate. And you know it's a unit circle, so you know r is 1. And you also know it's in the 4th quadrant. So that's me just basically writing down everything that's going on here. Now, since this is a unit circle, won't this circle be x squared plus y squared equals 1? Would you agree? Isn't that the equation of a unit circle? Now, if I tell you the y coordinate, shouldn't I be able to find the x coordinate by using this equation? So we'll see how that works. Well, x squared plus y squared equals 1. X squared plus -5/13 squared equals 1. X squared plus 25 over 169 equals 1. x squared equals, well, if you take 29 169ths away from 1, can you trust me? You got 144 169ths. Can you just trust that? You can do it in your calculator, but that's what you get. Now, what will the x coordinate be then? What's the x coordinate going to be? Or how will I find it? Maybe that's a better question. X squared is this.
Square root.
Right, agreed. Now, when you take the square root of something, don't you have a plus and a negative? Agreed. And this simplifies down to being one of two possible answers. The correct answer, because there can only be one correct answer in this particular situation, is one of these two. How do I know that it's this one and not the other one? I've used one piece of information. How do I know it's the positive x coordinate and not the negative one that's the right answer for this question?
In quadrant 4, x is positive.
You see it? And I'll make that. Now, after all that hard work, do you know the answer that you put in the book, or the Weber sign, is you've just put in 12/13. Now, do you need all of this? Probably not, but I think it's helpful if you see everything. Me visually, I think it's so helpful to draw this little circle. Couldn't you do without it and still come up with the right answer if you realize which quadrant it was in? But I think when I see it that way, it just sticks out as, yeah, I'm pretty sure I know.
So just
Yes.
to clarify, x squared plus y squared equals 1 is like true only in unit circles?
Correct.
Okay.
So if the circle happened to be radius 5, wouldn't I be doing x squared plus y squared equals 25 because it's radius squared for a circle? So if the radius was some other number, I would do that. Are we good? Right, let me try that. I'll make up a question where that is actually part of the puzzle. Suppose I tell you I have a point whose coordinates are, I don't know who you are, comma 4, and it's on a circle of radius 5, and that it's in the second quadrant, right? Now, I would draw this guy. If you tell me it's in the second quadrant and it's something, comma 4, would you agree that it's up here somewhere? So far, so good. Now, what do I know about a circle whose radius is 5? Well, I know that x squared plus y squared equals the radius squared. So I know that x squared plus 4 squared equals 5 squared, which is x squared plus 16 is 25, which means x squared is what, 9? And so x will be positive or negative the square root of 9, which means I have a decision to make, which is which one of those is the right coordinate in this situation.
Negative?
Would you agree the x coordinate here is negative? Agree? Can you see it? This guy, definitely negative. So you would put in negative 3, comma 4, and that would be that point. So essentially, isn't the only difference between these two is that the x squared plus y squared equals 1 if it's a unit circle, and the x squared plus y squared equals whatever that radius is, right? So if they tell you the radius, you're good. We good with that? Okay, see nods, I'm happy. The ones that I've been doing right now are questions 1, question 2. Versions of this question are 3 and 4. They're a little bit different, so I'm going to do a version of that. Question 5 is just the complete unit circle. So they get you to do a complete unit circle, which is fine. Let's see what 6 is right. That's it. Okay. So I now need to show you questions where the information is given to you a little bit differently. So this is my version of question 3. It's on a unit circle. So we're told that. We're being asked to find a point P, X, comma, Y. You've been told that the Y coordinate is -1/5. And you're being asked to find the X coordinate. And you've been told that the X coordinate is positive. So do you see in this case, they never told you which quadrant it was in, but they at least told you it's going to be positive. So if I was drawing my little unit circle guy, I'm looking for a Y coordinate that is -9, but the X is positive. Would you agree that P would be down here somewhere? Wouldn't that have a positive X coordinate and a Y coordinate of -5? So essentially, haven't they told me it's in the 4th quadrant? They just didn't do it that way. Now the equation for a unit circle, and X squared plus the Y coordinate squared. And things are going to get messy in a few seconds. What do I do to both sides to find X squared?
Subtract a 25th.
Now, if you take 1/25 away from 1, which is 25 25ths, are we okay with doing that all at one go and just saying it's 24 25ths? Are you comfortable where that came from? 1 subtract 1/25 leaves you with 24 25ths. Now, would you also agree that the next stage is to take square roots? And there is a positive and a -1. But don't we know that in this case, isn't the answer a positive one, right? They told us it here. So the guy that we're looking for is that guy. But that's not the answer I'm going to write here. I have to make that answer as pretty as possible. So we're going to have to do some algebra with square roots. Hopefully you're familiar with this. Aren't you allowed to take square roots of fractions and take the top square root separate from the bottom, right? That's one of the things you're allowed to do. Would you agree that the bottom comes out really nice and the top is that? Can we do, well, let me phrase it differently. What can we do better? That's good, like 90% good, but I want to be 100% good.
We can get, I believe it's 4 square root 6.
Okay.
Sorry, 2 square root 6.
Yeah, I knew what you meant. Yeah. And that's the ultimate answer. So this guy up here is 2 square root of 6 over 5. So do you see you're not always going to get nice answers? Can you imagine you're going to get root 3s and root 6s and 2 root 6s and things like that? And that's okay when that happens. Are you comfortable now about finding a missing X or Y coordinate from a unit circle, which is what these questions are dealing with? As long as you tell me which quadrant, or you tell me the Y is positive or the X is negative, as long as you tell me something, won't that be enough to make the decision between the plus and the minus choices? It looks like we keep on picking positives, but that was just coincidence. I'm going to introduce a guy that we haven't been told, or at least the term hasn't been used, and it's called a terminal point. So we're still on a unit circle. Oops. The terminal point very often written with the letter T instead of theta. I like theta, but they want T. I think they pick T because it starts with the same letter that terminal starts with. And I give you a guy like that. The terminal point is the coordinates of the point on the unit circle that corresponds to the angle pi. Okay, on this unit circle, where is the angle pi? So, right, you start off there, right? And you turn anti-clockwise until you get to an angle of pi. Where on my unit circle would that guy be?
-1, 0.
Would you agree it'd be there? And so the terminal point would be -1, 0. And that's what you would write in. So far, so good. Now, it's a good idea to have a unit circle handy. I haven't got a full completed one, but I'm going to kind of use, what I've got, because if I put pi there, wouldn't you see the answer we just got a minute ago, right? So I'm going to pick one on this shape that's easy, then we'll start making them harder. Suppose t is equal to pi upon 3. What are the coordinates of the terminal point for the angle pi upon 3?
√1/2 square root 3/2.
Would you agree it's this guy here? Okay. Now I'm going to pick one that is not on my picture. If I wanted to do 5/3, can you trust me it would be about here? Now, if you've got a completed
hang on,
unit,
5/3?
I hope so.
That's 2/3.
Oh,
Ah,
that 5/3. Thank you. 5/3. That one would be an answer, but only for 2/3. Right. If you've got your unit circle handy, you should be able to tell me what that guy is. What is the terminal point for 5/3?
5/3 is in quadrant 4.
Oh, I can't draw. So what's that one? Oh, that one's going to be 4/3. Okay, let's check that. 3/3, 4/3, 5/3, 6/3. Yes, you're right. Okay, what's the coordinates of that guy? That's why I should have a full unit circle in front of me when I do this, shouldn't I? So I can find 5/3. What's the terminal point? What's the coordinates at that point?
It's 1/2, comma, negative square root 3/2.
Correct. I may not look it because I'm not drawing good. So I'm hiding this guy because he's hurting rather than helping. Sometimes they're going to do this to you. That isn't directly on the unit circle, is it? What angle in the range 0 to 2 pi, which is what we want when we do these questions, what angle is that the same thing as?
3 pi/2.
And if you do 3/2 pi, can't you now see that it's essentially that guy there, isn't it? Right. And that guy there has coordinates, I believe, 0, -1. How about this terminal point. 5/4 pi. Can anybody tell me what quadrant 5/4 pi is?
The third.
So it's over here somewhere, right? So on your unit circle, shouldn't you be able to find that guy? What are the coordinates of 5/4?
Be negative square root 2/2, comma, negative square root 2/2.
And if you've all got your unit circle in front of you, can't you verify that? Suppose they gave you a terminal angle of -5/6 pi. There's my little unit circle guy. That's not really the guy that we want, is it? Can anybody remember how you get the angle in the range 0 to 2 pi for a situation like this? What do you do to that fraction? What calculation do you do to it?
Plus
You'd
2
add.
pi.
You add 2 pi. Agreed? Now, if you do that, you get 7/6 pi. Doesn't that make it a lot more obvious where it is? Which quadrant is 7/6 pi? Agreed? It's about there roughly, right? 7/6 pi. So again, I don't have my unit circle handy. What would that one be?
Negative square root 3/2, comma, -1/2.
Correct. Agreed? Now, as long as the terminal angle ends up being one of the guys in the unit circle, aren't you good to go? You can always find its coordinates. Don't really matter what number or particular value that they give you. So I'm scanning through these and I can't see anything that doesn't fit into that, right? So if I give you a terminal angle, which is these, and I ask you for the terminal point, can you tell me, are you comfortable that you could find it on the unit circle and write it down? You feel good about that? Do you want me to do more of these, or do you feel comfortable that you could do it?
I think I'm good.
Okay, then we shall move on to another guy. And this time we're going to get a guy called the reference number. Reference number. Of an angle. Here's its definition of what it is. The reference number of an angle is the positive angle, although you don't need the word positive, but put it in, is a positive angle it makes with the x-axis. So the reference number is an angle, right? It's a positive angle that it makes with the x-axis. So let's give you some examples of one. If I give you a terminal angle of pi/4, it looks like that. And its reference number is pi/4. Would you agree it makes an angle of pi/4 with the x-axis? Okay, so this guy would have a reference angle of the same. Now, suppose I pick that terminal angle, and in the box, I'm going to put what the reference number is. I wish they would call it a reference angle, because isn't it an angle? I guess they use the words just to make it a little bit different from each other. Now, which quadrant would 2/3 pi be in? Which quadrant would 2/3 pi be in?
The second.
Yeah, I see that. And if you were measuring it, wouldn't it be that way, right? But the reference number is this angle, right? It's the angle that the thing you've just drawn makes with the x-axis. So what angle is the reference number now? What's the size of that little piece here?
Pi over 6.
Nope, bit close. Any others? Not pi upon 6, but it's close to
Oh, sorry. Pi over 3.
pi over 3. Now, if you want to find that angle as a calculation, don't you take pi and subtract 2/3 pi, and you're left with 1/3 pi? Is that the kind of calculation that you were trying to do in your head, right? That's how you find it. Well, let's take someone in the third quadrant and see what that looks like. So let's take an angle here, that one there, and that angle is in the third quadrant. It's 5/4. But the one we want is the reference number, right? That guy. What size is that angle?
Pi over 4.
Now, if you're looking at what calculation would get you that, don't you take 5/4 and subtract pi to get 1/4 pi? Do you see in this question, it was pi take away the angle, but in this question, isn't it the angle take away pi? So far, so good. Now, there's one last possibility. Couldn't the angle be in the fourth quadrant, right? So suppose I have an angle, that angle there, and it's 11/6 pi, and I want to find this guy. What is the size of the reference number, the reference angle in this last situation? Or at least could you tell me the calculation I would do to get it? Anybody got this one?
Be pi over 6.
It would be. And to get that one, don't you do 2 pi, take away 11/6 pi to get pi over 6? Okay, let's see if we can do a little table. If you're in the first quadrant, the reference number is the same thing as the terminal, right? It's t. If you're in the second quadrant, won't the reference number, right? Remember this one here in the second quadrant. How would we get that? Well, it's pi take away t. If it's in the third quadrant, the reference number will be pi add t. And lastly, if the angle is in the fourth quadrant, the reference number will be 2 pi take away t. Are you happy about those 4 combinations on how you find what's called the reference number? I prefer the answer reference angle, but whatever. Reference number. Are you comfortable with those? I'm keeping that one there to help, because we're now going to do some more of these guys. And I'm picking really weird answers or questions. There'll be pretty weird answers as well. for each one of these, we're going to find what the reference number is. Okay. Since I want to use this formula and I don't want to draw my circle because there won't always be exact values that we can go, we need to have, or we need to know which quadrant each of these guys are in. It might help if I do a little baby guy here. 0, half pi, complete pi, 1.5 pi, and I guess 2 pi. Which quadrant is 1/7 pi in? So one of these four, which one is it?
The first.
Great. Where would 3/5 be? And say yourselves things like, is it bigger than a half, or bigger than pi, or less than pi, or things like that? What is 3/5? Where would it be?
The second.
Right. Would you agree 3/5 is bigger than a half, but less than pi? Doesn't that make it same? Be careful, in case you think there's a pattern here. Where is 8/5?
The fourth.
Third?
Third or fourth? Which is it? Because it's one of those two.
It's the fourth because it's above 1.5.
Right, so 8/5 is about 1.6, isn't it, roughly? 8/5 is 1.6. Isn't 3/2 only 1.5, so it makes it in the fourth? Which quadrant is 11/3 in? And that's a trick question.
Wouldn't it be in the second?
Tell me why.
Um,
I like your
because-
answer. I just want to know where you get it from.
Yeah, because you'd have to subtract 2 pi until you got it to a number in between 0 and 2 pi.
Now, where is 5/3 then? Now that you've told me that. You want to change your mind.
Yeah, it's in the third.
Okay, are you sure?
I think
You've done
so.
it. Okay, a third, isn't that 1.667 roughly?
Yeah.
And isn't that guy bigger than 1.5? So it should be here.
Uh-huh. Yeah, you're
So
right.
take your fraction, figure out what decimal it is, and it might help you figure out which quadrant, right? So if it's 1.7, right, won't it be here? If it's what would that be? I'm trying to say 1.7 pi. Okay. So if it was 1.7 pi, it would be what I just said. So anything bigger than 1.5, anything bigger than 1, anything bigger than 0.5, right? And obviously 0 and 2. So if it's 1.7 pi, do you see it's here? If it's 0.8 pi, do you see it's here? If it's 1.2 pi, do you see it's here? You know, maybe that's a way of coping with, you know, the 7/3 and the 2/3. Now, once you've got these guys, especially this one, when you want the reference angle, don't you then have to kick in with one of these formula? So if you're in the first quadrant, won't the reference be the same guy that you started with? If you're in the second quadrant, it's pi, take away t. So it's pi, take away 3/5 pi. And the answer to that one is 2/5 pi. If you're in the fourth quadrant, isn't it 2 pi take away the angle? And I believe that is 10 take away 2/5 pi. And if you're 5/3, it's 2 pi again, take away that one, and I believe that leaves you with 1/3. So far, so good. Reference angle. What angle does your terminal angle make with the x-axis? And I just thought of one that I didn't do. I would like to know the reference number for that guy. Now I need to know, right, which quadrant he's going to be in, right? And before I do that, don't I need this guy to be in the range 0 to 2 pi? Okay, how do you find out what that guy is? Because the answer is actually going to be very simple when you see it.
Just add 2 pi.
Okay, so if you take that and you add 2 pi, I believe you get 15/8 pi. Would you agree that that is in the fourth quadrant? Agree? If you do it as a decimal,
Yeah.
it's 1.78, whatever it is, bigger than 1.5, so you know it's in the fourth quadrant. Now, to get that missing angle, don't you use the fact that the reference angle, right, the reference number is 2 pi, take away that guy, which ends up being 1/8. You see that? Kind of interesting, the similarities. Now, I'm doing a lot of fractions here, and this might be a good point for me to just show you that the calculator can do that for you, especially when the fractions are really ugly. So let's pretend that we had an angle 17, try to think of what that would work with. Want a fourth quadrant, so 2 pi, so
17/9.
Yeah, that'd be a good choice. So I want to take 2 and subtract 17/9 from it. Now, if you hit the button on your calculator, you get that. But if you press math button and choice 1, it turns your answer into your fraction. So the answer would be, in this case, 1/9 pi. So if the terminal angle was 17/9 pi, right, the reference angle would only be 1/9 pi. Are we good with that? Do you need to say any more of these, or are you comfortable with these? I want to see some more examples of terminals being turned into reference angles. I don't mind, whatever is best for you, love. Okay, I'll do some more. This, I'm picking some from question 11 here. They have a terminal angle of -9/11 pi. So the first thing I'm going to do with that is add 2 pi so I can get a normal, angle out of it. So since I got my calculator here, I'm going to do these with the calculator. -9/11, add 2, do the math button, choice 1, and it's positive 13/11. Now, when I look at my 0.5 of a radian, 1 radian, 1.5 radians, and back to 2, I need to figure out which quadrant that's in, because whichever quadrant it's in influences which of these formulas I would use. So if I take 13 and divide it by 11, I get 1.18. Would you agree that 1.18 lives over here somewhere? And that's how I know this angle is in the third quadrant. See how I did that? Yeah. 13/11 might not be an obvious one, but if you turn it into a decimal, can't you use these guys here to figure out who it is, right? It's roughly 1.18, isn't that somewhere between 1 and 1.5? That makes it this guy. Now, since it's a third one, to get the reference number, it's pi plus the terminal angle. It's going to be pi plus. When you're in the third quadrant, it's t, take away the permanent one. So it's, nobody caught that in a stroke. it's t, take away pi when it's in the third quadrant. So it's 13/11 pi, take away pi, which I can do in my head is 2/11. But you could do it in your calculator as well. Let's pick a really weird one that I just noticed. T equals 7. We want to find its reference number. It isn't even a multiply 5. Does anybody know what quadrant 7 radians is in? Which do you think it is? Oh, 1, yes, you're right, Caitlin. You want to share how you know that?
Well, I just went by multiples of 2.
Oh,
Oh wait, wouldn't it be in second quadrant?
no, it's going to be what you said, the first quadrant. Right, here goes. Wouldn't you agree that if you start at 0 and go all the way around, you do 2 pi? You agree? Now, 2 pi is 2 times 3.14. So isn't that roughly 6.28? Isn't 7 all the way around and just a little bit bigger? So it's back to the first quadrant, which is, I believe, what you told me. Now, let's check that on the calculator. If you do 7, which is bigger than an entire revolution of a circle, and you take away pi, or sorry, take away 2 pi, 7, take away. Oh, I hope it takes it that way. You get that this fella is 0.717 roughly. And since it's in the first quadrant, it's still 0.717. If you wanted to do it as an exact value, won't it be 2 pi take away 7, which is essentially what I just did. Do you want me to do some more of these guys, or are we better? Okay, I'm getting more shakes. I'm happy to move on then.
I missed the triangles.
You miss them already? Too late. They're gone for a while.
I don't like the circles.
Maybe you'll change your mind. It can happen. Right. Just get myself semi-organized here. Our next section is going to be using the unit circle to find exact values for standard angles. And
Would you mind
yes.
doing, before we move on, would you mind
Hmm?
doing another one of those whole number ones?
Sure. So let's do a t equals 5. Now, I have to know which quadrant that guy's in. So that's what, 0. That would be pi upon 2. This would be pi. This would be 3 upon half pi. And this would be back to 2 pi. But since this one has got a number, it's not a multiple of pi, it is a number. I'm going to convert these guys into decimals. So this one is roughly 3.14. Would you agree that this is bigger than that? Right, I'm going to find out what 3 upon 2 pi is a decimal. So if you do 3 upon 2, it's like 1.5 times a pi. And roughly, I get here 4.71. So far, so good. Now, if I do 2 pi, can I just say 6.28? And if I do this one, it's a 1. What's that going to be? 11.57. Right. So the terminal angle is 5. And if I kind of use these as like a clock face, would you agree that 5 is roughly there? And that is in, by this particular example, would you agree that's in the 4th quadrant? Great. Now, how do you get the reference angle when you're in the 4th quadrant? The formula is 2 pi take away t. Agreed? Right, when you're in the fourth quadrant, the reference angle, which is basically this green guy here, is 2 pi, right, all the way around, and take that bit off, and what's left is him. So in this case, if I left it like that, it would be 2 pi take away 5. Or if you want it as a decimal, you'd have to do some rounding off, but 2 pi subtract 5 is about 1.283 if you want to do 3 decimal places. So you have to use decimal values when the terminal angle is a number, right? If it's not a multiple of pi, you should use these guys here to determine the quadrant. Now, once you know the quadrant, don't you just use, if it's in the first quadrant, it's the same guy you started with. If it's this quadrant, that quadrant, and so on. You could get it that way. Do you want to see another one? Or does that
Nope,
help?
that helped. Thanks.
Okay. Now, back to my really ugly unit circle. I'm going to make a print out of this guy for tomorrow so I can use my various printouts. I got some key points along here, so I'll put those guys back in. So this one is root 3 upon 2 a half. This one here is root 2 upon 2. This one here is 1/2 root 3 upon 2. This guy that's kind of directly opposite it is going to be negative 1/2 root 3 upon 2. The next one down would be here. So that's going to be negative root 2 over 2, positive root 2 over 2. And the last one, which is opposite this one, is going to be negative root 3 upon 2, comma, a half. And can you imagine that there's going to be 3 more here and then 3 more here, right? And the angles, that guy is pi upon 6. This guy is pi upon 4. This guy here is pi upon 3. You got this one, you got this one, you got this one. This one here is 11/6 pi. This one here is 3/4 pi. And this one here, what is this one here going to be?
Wait, that's 5/6 pi.
5/6. Thank you.
No, no,
So-
no. I'm saying the 11/6 pi is 5/6 pi.
Oh, this one. Yes, would be 11/6 as much. This one here should be what?
2/3 pi.
2/3. Right. Which is why you should have unit circles. And off you go, and off you go. So you're being asked to find the exact value of certain trig ratios. So find the exact value. So if someone says to you, the sine of 2/3 pi, is the sine the x or the y coordinate of the terminal point?
Y.
Okay, so the x coordinate is the cosine of an angle. The y coordinate is the sine of the angle, right? So if I want to find the sine of 2/3 pi, don't I find the y coordinate of this guy? So if I find 2/3 pi, which is this guy, isn't his y coordinate root 3 upon 2? Right, angle, y coordinate. Suppose I asked you for the cosine of pi upon 6. Then the cosine is the x coordinate. If you find pi upon 6, it's this guy, and the x coordinate happens to be that one. Suppose I asked you for the sine of 3/4 pi. Right, there's 3/4 pi, and the sine is its y coordinate. And the y coordinate is root 2 upon 2. Suppose I asked you for the cosine of 3/4 pi. Well, there's 3/4 pi, and the x coordinate of that point is the cosine, and that's -√2/2. Would you agree, as long as you've got your unit circle in front of you, can't you find the exact values for sines and cosines by finding the x or the y, whichever is appropriate, coordinate? Are we good with that idea? Now, suppose they ask you for the tan of pi upon 6. Well, the tan is a little bit trickier, isn't it? Actually, the y coordinate divided by the x coordinate. Right? That's the formula for it. And if you take pi upon 6, which is this one, and you take the y coordinate, you get a half. And if you take the x coordinate, you get √3/2. And for some questions, you're going to have to do some tidying up. That's the answer right now. You agree that's not going to be the answer we finally get to. You know we have to make it look pretty. If you take a fraction that has a fraction on the top and a fraction on the bottom, you take the top and you multiply by the reciprocal, right? So top fraction multiplied by the reciprocal of the bottom. Are you happy with that part? Would you notice, and this will happen a lot, that you get a lot of cancelling? Would you agree that's quite a nice answer compared to what it was a few minutes ago? Do you think that's going to be the final answer? Can we make that look better mathematically? And what we do in this case is you multiply the top and bottom by that, and that's called rationalizing the denominator. And we think of that as being a better version than that, because it doesn't have a square root in the bottom, essentially. So far, so good. How about finding the tangent then of, I've done 6th. Yeah, let's do the tangent of 2/3 pi. Won't that be the y coordinate divided by the x? And this time it's going to be √3/2 divided by -1/2, right? Y coordinate divided by x coordinate. That's going to be the top fraction multiplied by the reciprocal. And in this case, oh, the answer was a lot quicker, wasn't it? Easy to fix. Can you hear my little dog barking in the background? Yeah, she's wanting attention, but she'll just have to wait. We're almost done. How do you think we should tackle a question where the angle isn't between 0 and 2 pi?
Should you, since it's a negative, add 2 pi to get like the other angle?
You would. Now, can't you find that on your unit circle? Right. I believe it would be this guy down here, right? That would be it. And that guy happens to have an x coordinate of √3/2 and a -1/2. And so since I'm looking for a sine, aren't I looking for a y coordinate? And this case, the y coordinate should be -1/2, provided I got my unit circle. Now, you can do this as a backup check, but don't do this as a replacement for what I've just done. I want to know, is that really -1/2, right? Because maybe I got the x's and y's switched around or something. If you go to your calculator and you make sure that you're in the right mode, in this case, you make sure it's in radians, which I've now done. I can do the sine of -pi divided by 6. And hey, does that look like -1/2 to you? It does to me. Now, what about weird ones like that? It also works. If I go tan of, what's that, 2/3 pi? So I'll call that 2 pi divided by 3, which is the same thing. I'm going to get a really ugly negative decimal, I hope. You see that really ugly negative decimal? What I'm now going to do is find out what negative square root of 3 is. And shouldn't it be the same ugly decimal? So you need to do this, because won't this not work? Because you don't know what ugly, square root of 3 over 5, whatever, right? You don't know what that is, but can't you, after the event, use this to check? You got what you believe the answer is, and then the calculator will verify it. Now, I guess